So let's look at this next one. It says, which of the following statements are true? It says, okay, we're looking at the point A here, f of A. And it says, the limit as x approaches a from the left and the limit as x approaches a from the right exist but are not equal. So if I look at the limit as x approaches a from the left and right, I can see that they're approaching the same y value. So this one is false. F is continuous at x equal a. So the limit exists and the point A fills the hole. So this one is true. The limit as x approaches a from the left of the derivative, and the limit as x approaches a from the right of the derivative exists but are unequal. So what that's saying is I'm looking at, as I'm coming in from the left and right, is the slope of my function the same coming in from the left and the right? And I can see that the slopes don't match up. They're not, it's not a smooth matchup on the slopes. And so this one is also true. And then the limit as x approaches a of f of x minus f of a exists. This is the derivative, right? And so this is the limit, left and right hand limit of the slope. So this one is false because this is the definition of derivative. And since the left and right hand limits of the slopes don't match, the derivative doesn't exist. So the two that are true are 2 and 3. So D is the correct answer. All right, so for the next one, it says write the graphical quantity for the blank. So f of a, so this is my a here. I'll just highlight it. So that's my a. So f of a would be the coordinate of the function f. So I see that f is that curvy black line when x equals a. So the correct answer for that would be this capital A. For h is this distance here. And so that would be E in my picture. Okay, f of a plus h minus f of a. So this is the change in y from f of a plus h to f of a. So this is f of a plus h, and this is f of a. And so the difference between those would be this distance here, f. F of a plus h would be, here's a plus h. A plus h is here. And I follow it up and over. F of a plus h is the quantity b. F of the limit as h approaches 0 of f of a plus h minus f of a over h, that would be the derivative. So it would be the slope of this tangent line, which would be c. And f of a plus h minus f of a over h, that would be the slope of the secant line. So that is going to be this point D. The secant line that goes through the points a f of a and a plus h f of a plus h. So that line there, the slope of that line there would be D. Okay, so for this one, I want to evaluate all these points. And so I'm looking for the limit as x approaches 1 of f of 1 minus f of x over 1 minus x. This is going to be the derivative of the function at x equals 1. And so if I look at when x equals 1 and I go here, the derivative at that point is 0. F prime of negative 1. And so I'm going to look at negative 1 and I see that there's a cusp here. We have a pointy, a non-smooth part of my graph. So this would be D in E. There's no derivative at that point. The derivative doesn't exist at those cusps. As x goes to negative 3, what is the limit of the derivative? So as x goes to negative 3, the right hand limit would be 0, and the left hand limit would be whatever the slope of this line is. So the left and right hand limits don't match, and so this limit does not exist. This is the definition of derivative evaluated when x equals negative 2. So I can look at the graph at negative 2 and see what the derivative is there. And I see that at negative 2, the derivative is 0. The slope of that tangent line is 0. F prime of negative 4. So if I look over here at negative 4 and I can see that I have this line with a certain slope, I can see that if I go over 1, go up 4, so the slope of that line is 4 over 1. So the slope is 4. The limit as x approaches 3 of f of x. So if I look over here at 3, the limit as x approaches 3 of f of x, as I come in from the left and the right, the y values are approaching 0. So since the left and right hand limits are the same, that limit exists and it's 0. The limit as x approaches negative 3 of f of x. So if I look at negative 3, I can see that as I come in from the right hand side, it approaches the y value 2. But as I come in from the left hand side, it approaches the y value 4. So since the left and right hand limits are not approaching the same value, they're not approaching the same y value, then this is D and E. The next one, as x approaches 2 from the left, so as x approaches 2 from the left, we're looking here, so I'm going in from the left-hand side, approaching 2, and that's approaching the y value 1. So that's it for this one.